Hi, my name is Mark Pierne. I'm a principal architect for API and integrations in the Technology Services organization at F5. In this presentation, I assume you've been oriented to the basics of event-driven architecture. So today, we're going to take a deeper technical look at how F5's Technology Services organization has leveraged event-driven architecture to achieve a federated engineering approach. We'll discuss use cases focusing on around our price and quote domains, architectural agility, and order microservices. We're centered around an end-to-end API security approach. More importantly, we focus on a human-first approach in our engineering practices. At F5, we've been using Solace and Kubernetes to auto-scale as an event mesh to achieve secure and reliable communications between canonical API data domains. This has allowed us to manage our data efficiently, respond to changes in real time, and ensure scaling accurate pricing and quoting with our new SKU data models. This reduces time in our new product pricing delivery. With the event mesh, we've been able to decouple our technical services teams with microservices, allowing them to work independently and efficiently. Additionally, we've implemented a blue-green approach for deployment and disaster recovery to incorporate the high availability features that are built into the event mesh. One thing to understand technically upfront, to scale any federated engineering practice is efficient and event-to-queue environment management. For the patterns we will discuss today, decentralized engineering teams need to understand their data domain and what scales for them and their community they interact with. You may have teams who have compliance, low capacity support, or other factors that impact the implementation of your architecture. So I guide to use a variety of options to consider as guides, not mandates. One queue for all lower environments by topic path, root dev, root test, root stage, or root prod, or for more disciplined engineering teams, root blue and root green, can simplify your architecture and reduce management overhead. You will want automated end-to-end testing flows in this case to ensure a balance for root blue and root green set of practices. You can use topic subscriptions to filter for each environment. However, if you have data domains that need to ensure complete isolation between environments, using one queue per environment may be a better approach for resource management. For complicated situations, one thing you can consider is a hybrid approach, where you use multiple queues for each environment, but group them by topic path. For example, you could have root dev in a queue for all messages related to the development environment, and then sub-queues within that queue for specific application components or modules. Understanding how to technically adapt or auto-scale your event management in real time directly relates to the scale of federated engineering practices that we will discuss in this presentation, or that your engineering teams will be able to accomplish by effectively scaling as a community. One of the key patterns we employed at F5 is the fan-out pattern, which allows us to distribute messages from a new product SKU data models within price and quote data domain to other systems data domains. This ensures all relevant systems receive necessary pricing SKU information. The value add is being able to deliver our product models faster throughout our technical ecosystems. At the same time, this allows us to scale our internal software services in a cost-effective way over time that as new data domains enter the ecosystem or applications that may need to consume that data, they have the ability to in a cross-domain manner. That makes it applicable in real time as changes may occur to the data model. To improve data quality and governance practices, we've been exploring a data catalog and developer portal to drive data intelligence solutions. This has allowed us to identify insights and patterns for more decision-making and to being more decisive with our data, while also ensuring that our data is properly governed and high quality. Our approach is multi-cloud, which can make things difficult, but to utilize the best cloud for each service or software that may be working within each domain. Additionally, we've begun implementing best practices for surfacing data domains for communal consumption. We're currently iterating and expanding the use of our portals, so this is probably a presentation in itself for later on. By using the event mesh, publish subscribe patterns, we've been able to securely and scalably deliver asynchronous events to appropriate systems. This has allowed us to design single order microservices in a unified distributed messaging backbone, further decoupling our systems and implementing efficiency. When an order is received, it's published as an event on the event mesh, and relevant microservices can subscribe to that event to receive the data they need. This allows for asynchronous communication between a variety of systems, ensuring that they can operate independently and efficiently without worrying about complex point-to-point integrations. Scaling our services efficiently year over year by proper patterns and protocols is directly profit for our business as we operate. Open-based engineering community by code, API type, or protocol directly enables that profitability to scale over time, as choosing the proper one ensures that it's efficient. Sharing order data between Salesforce and other internal services can be a challenge for very active relationship models. But with our event-driven architecture, we're able to achieve this fairly seamlessly. By focusing on core functionality, designing to process customer orders quickly and accurately, we've been able to avoid the need for adding legacy, complex, brittle integrations between systems. This is another area where we also use the publish-subscribe pattern for real-time activity as we transform our business from its perpetual sales routes internally to its subscription-based future. So it's not only to scale the relationship of our customer, but it extends the relationship model throughout our engineering ecosystem. At F5, we believe in a federated engineering approach that enables cross-functional teams to collaborate and innovate. We work hard to keep an open engineering community. We leverage our engineering community for the ability to create innovative designs that, as our expertise grow in different areas while decentralized, our centers of excellence distribute that knowledge across domains. This enables decentralized designs with microservices and APIs, architecture, and emphasizes sharing knowledge across data domains, as it gives everyone a common approach of way of building at F5 that really promotes a fun way of working with each other, especially with those that have different domain expertise. Not everybody knows everything. So this is one way you figure those things out and resolve those problems. We leverage agile methodologies with teams working in sprints to deliver value quickly and iterate even faster. This allows us to respond to changes in the market and with our internal needs. Choreographed and orchestrated events are a critical component of our federated engineering approach. By leveraging Solace's event-driven architecture, we ensure that events that are choreographed and orchestrated in a way that supports the need of our business. After all, we're all business people with engineering skills. This allows us to build responsible and scalable systems that can adapt to changes in real time. We typically begin with looking at all of our natural events that are choreographed before we look at any type of orchestration that's needed. We then combine those to find the best patterns that are used by distributed teams, and they're decentralized. So as they figure out within their domain what works best, they feed those back to larger COEs that can communicate and get those out to larger groups for larger initiatives. Our approach balances integration patterns with a variety of engineering paradigms, like core SaaSes, similar to Salesforce, Workday, or other SaaS-based internal systems. This enables us to integrate third-party systems and maintain a clear view of our data while doing it. This balances with our coding teams, building software and using a variety of languages such as Go, Java, Python, TypeScript, Rust, or other languages. These patterns can be scaled back from those smaller teams to larger initiatives. And that acts as interactive frameworks that each data domain discovers with new innovations. Those innovations become scaled back, and that community has a reusable set of domain expertise. At F5, we're always looking to innovate and improve our systems. Recently, our internal integration center of excellence has been exploring our internal use of F5's NGINX software as a service gateway with Azure. Its service mesh capabilities for microservices, which allows us to benefit from a future state with App Protect and auto scale using the service mesh. And this gives us an internal direction to further incorporate end-to-end API security solutions using the F5 product line. This helps us to build a secure and scalable microservices direction. And after all, everyone enjoys sleeping well at night. So having that security of your own internal product set with F5 in coordination with the events and microservices of the event mesh has a good balance between our dynamic, imperative, or cloud native engineering systems and teams. Finally, our approach at F5 is centered around a human-first approach. I probably sound a little robotic today. However, our leadership encourages us to work in teams into smaller specialized units, allowing individuals to work independently and collaboratively towards common agile goals. By achieving robust security measures, iterating on governance practices, decentralizing the engineering, and enabling advancements with data and innovation, we're able to drive success across our technology services organization. So while I dove a little bit into the kind of the technical way of the federated engineering working, it really is makes it a lot of fun when everyone begins to speak the same language. And our leaders at F5 really encourage that. F5's technology service organization has gone above and beyond by embracing event-driven architecture. And let me tell you, it's been a game changer. Those kind of cultural adoptions and changes are very difficult. And any group that takes that on, they need to be aware of that. But also making sure that you understand the technology that scales that community is very important. So like everything at F5, we started with that secure API-first approach and a human-first mindset. We keep an eye on creating comprehensive reusable solution architectures and scalable engineering practices. We federate that as an engineering community that makes it fun to work together at F5 because F5 is always a force for innovation. Well, thanks for tuning in, and we're at the end of my presentation. It's been a pleasure, and I look forward to next year.